Assuming the above conditions are met, which we did in the last video, samples from 2 different populations yield the following data. Blah, 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 right? The sample size is the same for both samples. Find the 85% confidence interval. So let's have a go at this. Looking at the back of the exam sheet there, I'm going to go with a formula like this: x bar 1 minus x bar 2. That's going to be our estimate for mu1 minus mu2, and then we're going to need error, standard error, so it's going to be plus or minus our t-stat multiplied by dot for multiplied by something like our standard deviation. I'm getting that from the bottom of the formula there for the t-stat on the back of the exam sheet. So that gives me t multiplied by s1 squared over n1 plus s2 squared over n2. Okay, now where are we going to get our t? Oh yeah, we're going to need to work out degrees of freedom as well. So in order, we're going to have to look up our t value from the table, right? So we're going to get our t-stat from the table C in the exam sheet, right? The degrees of freedom then is going to be a complicated one. I'm going to copy in the formula for that from the back of the exam sheet. So here's our degrees of freedom formula, which we need the degrees of freedom to know what row to look up on the exam table, or in the table C, right? So we've a kind of a big messy fraction here, and on top we've something squared, and we've 2 fractions here. n1 downstairs here, they're both going to be the same, 478, n1 and n2, sample size 1, sample size 2. S1 there is 77, it's going to be squared, that's going to be 88 squared. And underneath them we've 1 over n1 minus 1. Well, n1 minus 1 is just going to be 477 times 77 squared over 478, square all that there, plus 1 over 477 times s2 squared is 88 squared over n2, which is 478. So careful use of the calculator required now to get our degrees of freedom. So I'm going to bring up the calculator here and take care of a fraction key, and on top then I'm going to have a bracket, close bracket, that's all going to be squared, and inside in this bracket I'm going to have fraction key, 77 squared there, 478 below, plus fraction key 88 squared downstairs with 478, and then below that again I'm going to have 1 over 477 multiplied by, bring it out there with a key, multiplied by, open bracket, fraction key 77 squared over 478, bracket there, square that, plus 1 over 477. It's going to be multiplied by the bracket there, fraction key 88 squared over 478, close the bracket. Now that's a big long mess, but I'm going to press equals, and I get 2295.106, 2295.106. Jeepers, that is big. Yeah, degrees of freedom was on the table here in front of me. Degrees of freedom go up as far as 1,000. Alright, so we're dealing with it's heading towards Z, the Z row on the table there. So the sample size is very large. So maybe we can just use a Z-stat instead of the T-stat. So the Z, yeah, so I would go maybe with the Z-stat. As you can see, I'm no expert at this stuff. X bar 1 minus X bar 2. And now I'm going to go with the Z-stat. Times this guy here. Right, and now I'm going to get the table and bring it up here. Now looking at table C from the exam sheet, say like the classic one would be Z is equal to, if for a 95% confidence interval, Z is equal to 1.96. Now that's not the case in this question, but look, just to give us a kind of a grounding, there's Z equals 1.96, right, for 95% confidence interval. You see the 95% is up there, but we're dealing with 85%. And it's not even on the table, so it's going to be in here somewhere, right? So it's going to be between these two figures. Okay, so maybe we're looking at the wrong page. So I googled it up there. I looked up the Z score for an 85% confidence interval, and I'll show you what I got there. There it is. I got Z equals 1.44. So that's the Z we're going to use. Right, so back to this, we're going to use this formula here. I'm going to copy that down. There it is there. And we're going to start putting in the values. So for Z, we're going to have plus or minus 1.44 multiplied by, so I'll put that in brackets, the square root. I'm just going to fill in our values here, and it was 478. Both samples were n equals 478. Something squared here, something squared here, and x1, x bar 1 minus x bar 2. So I'm ready to put them in. I'm going to scroll up here. X bar 1 is 958 and 157. 958 and 157, plus or minus this, and then we've our S1 and S2, 77 and 88, 77 and 88. So calculator, 958 minus 157, we get 801. Plus or minus, and this is going to be our standard error when we work all this out here. So we have 1.44 multiplied by, and I'll open a bracket, don't really need a bracket but it'll do no harm, square root of fraction key 77 squared over 478 plus another fraction, and we've 88 squared, also over 478, and toggle out there with the key, write out and stick in the closing bracket and press equals, and we get 7.701 or 7.70, the two decimal places, 7.70. So that's our confidence interval for what? It doesn't say, there's no units or anything. So that's our answer, that's our estimate, plus or minus 7.70. This is our 85% confidence interval for the difference of two means.